in the marsh. They're easy to see once you recognize what you're looking at. I'm going to kind of skip away from the pedology part about it, but talk about their significance from a standpoint of land use. We're in the Blackwater Wildlife Management Area owned by the Department of Interior. They actually have an aggressive program for buying land, additional land. Surprisingly, they actually came to us and asked us where should we target. And we told them, well, what are you trying to target for? They go, the expansion of the marshes. And we said, we have just what you need. These soils which are called sunken or Othello or Elkton. Particularly the sunken, because it's showing you where the tidal marsh is starting to creep into the upland. So they've used the soil survey information to target areas for purchase or easement. So that's one of the uses of our mapping of the sunken type soils in these sinking landscapes. Another area that I deal a lot with is cropland, which is being abandoned or being damaged by the salt and subsequently abandoned. Everybody knows we're having climate change, we're having sea level rise. So a lot of these areas, and down here it's about 4 millimeters per year of sea level rise. Well, these areas, so what is that? 4 millimeters per year is 40 centimeters. The 40 centimeters?
4 centimeters every 10 years, right?
Which is 40 per century. Yeah. So we've had 1.2 meters in the last 300 years. So a lot of areas which were farmed are now being inundated by salt. Well, after Sandy come through and we had a few breaches in our barrier complex in Delaware, there are a lot of areas were farmed for generations, 5, 6 generations. These areas are now salt damaged. So what do the farmers do? The first thing they do is they buy some diesel, get a piece of yellow equipment. They go right to the tidal marsh edge, start digging, and they build berms all around their crop fields. The only problem is these are lowlands. Therefore, we have drainage ditches. So if they don't design a drainage structure that accommodates tidal surge, and that is it opens and closes depending on the tide phase, the water comes in and around their berm and stays in. So we have salt damage. So they have salt damage. They call me. I go out. They say, Phil, what can I do? I said, there's only 2 options for you. I said, you can leave it alone, or you can try and get a little bit of money from the government. We have programs, Conservation Reserve Program, WRP. So we're talking to farmers about putting these things into easement. At least they get some money for them. We get the wildlife benefit and the wildlife habitat benefit of it. The big questions we have now is how to reestablish the vegetation. The problem we have when these areas first get inundated and they kill everything is Phragmites and poison ivy come in, and that's about the only thing we can get established. So we would love the university at one of the wonderful schools like Rhode Island, University of Maryland, Rutgers to do a study to tell us what type of species we should be planting so they will thrive and therefore keep out the Phragmites and the poison ivy.
That's why we're doing this ESD stuff, Phil.
Yeah, okay. When you get one done for this area, send it to me. So the big takeaway from this is how landscapes are changing in our lifetimes and how the soils are changing as well. We can see the effect on the land from its management and use. We can actually see the change in the soil profile, particularly at the chemical level. And I will let Del Fanning talk about the sulfides being formed in these soils right now, because I'm done. I'm worn out. I'll only answer questions from this point on.
We got about 6 minutes to get on the bus.
Okay, Del, you want to do
Well, I think we could tell the stories another time I've told them. But I'd just like to mention Bob Darmody, who was our first graduate student to study these things. And he actually recognized that 3 main kinds of marshes. And these are the ones called the submerged uplands.
Correct.
Because that's what they are out there. You've got peat on top of soil that was upland. And they get converted, first of all, I guess, from ultrasols to alpha sols because the change in the base saturation.
Yep.
But then subsequently they've developed histocapipedons and then eventually become histosalts.
That's absolutely right.
Sulfide MS or whatever.
Right. And
but the sulfur part of the story is that to get the sulfides in them, the sulfur is coming from the seawater. Seawater has about 900 parts per million. Sulfur is sulfate, I believe. And that sulfur with the organic matter gets reduced. It forms hydrogen sulfide, which we can smell and walking over some of the marshes and so forth. And that hydrogen sulfide reacts with the iron oxides and makes iron sulfides. And actually Marty is, some of his, I thought it was best work he ever did. He came out here and buried some of our Christiana, which is a B horizon of an ultrasol. It has about 5% iron as iron oxides. He buried it in some bags out here and came back in 2 years and found out on the outside of that it was all black and converted to iron sulfides, and actually pyrite framboids in the cracks. And from that, actually, we deduced that the reduction of the iron is probably happening by the sulfide. The sulfide reduces the iron, and some of it goes to form pyrite. Some of it doesn't. Sulfur doesn't get reduced, and that's when we get the monosulfide. And for other groups here, I've done it. I'm not going to do it again, but if you get some of the stuff that's down there that's black, there's monosulfides being formed right here now from the iron oxides that are in the soil, and right around the organic matter you'll find all this black stuff. And if we put hydrochloric acid on it, which I have here, you get a nice odor of hydrogen sulfide. That's a test for monosulfides. Actually, pyrite doesn't do that.
That's right.
I think that's enough story if we got to get on the bus. So.
How's our time, Joe?
All right, thank you.
Any questions?
Yeah, I got a question. I didn't quite understand. So how did the